And now you can see the local loop may contain your coaxial cable, basically coaxial cable or twisted pair. Normally in the past few years we were using only twisted pairs in the local loop, which were connecting your landline phone to the local exchange. Then you can have changes, or you can have a coaxial cable connecting from end office to the toll office, and you can use microwave or the satellite communication between toll offices and the switching offices. So now basically why we are calling them intermediate switching offices, because here you are doing switching from one one line to another line, and you had switching offices which were doing the communication. So in context of this telephone system, which is shown in figure 2.3 here, now we'll be discussing the switching concept. Switching, there are two types of switching which are used in the phone system. One is the outside plant, that is the local loops, trunks, since they are physically outside the switching offices. So ये जो सारा का सारा है outside plant कहलाता है. So there are two parts basically. One is the outer plant, which we have just discussed in the figure here, and there is inside plant, which are the switches, which are the devices which are inside the switching offices. So जो major hexagonal pic आपने अभी देखी थी 2.30 में, जो middle part था, that was the switching office, and there we had those switches. We have those switches, the devices which are doing the actual switching part. So that is the inside plant. So outside plant, we have already discussed the local loops, the coaxial cables, twisted pair, the hubs, switches and routers. So all those things already how these actual switches inside the office. That we'll be discussing in this particular topic, switching. So there are two types of switching techniques which are used in the net now. Switching and think we also is so first we discuss switching techniques, both the switching techniques, kit switching and packet switching. Actually, when computer or a telephone places a call, टेलीफोन में जब आप प्लेस करते जैसे ट्रेडिशनली आप करते थे हमेशा पहले, तो स्विचिंग इक्विपमेंट क्या करता है टेलीफोन सिस्टम में, सीक्स आउट अ फिजिकल पाथ फ्रॉम योर टेलीफोन टू द टेलीफोन. सो व्हाट इज हैपनिंग दैट switching a path, and sometimes you must have remembered that when you were using the landline phone calls, you used to dial the number, and then there were few seconds, like 5 to 10 seconds gap, and then your phone would connect. Otherwise it would just give you a beep, an engaged beep. डू यू रिमेंबर द ट्रेडिशनल फोन को आप जब भी करते थे, आप जैसे आपके पेरेंट्स करते थे, आप कभी लैंडलाइन फोन को यूज करते थे, तो या तो वो बीप देगा एंगेज टू टू काइंड्स एंड दैट द फोन इज एंगेज और द लाइन इज बिजी, और इट विल जस्ट आफ्टर 5 to 10 seconds it will just connect and the bell will on the other side will ring. That was basically doing circuit switching. So that time when you have just dialed the number on your phone, it was seeking a path from your phone to the receiver's phone. So it was making a connection, it was making a circuit and finding a path, circuitry, the actual path from your phone to the destination phone. So you can see it in next figure 2.46. Now see this first figure, topmost figure A. This is the telephone system. So suppose this the telephone on the left hand side wants to make a call. So you can see the first circle in the first rectangular box. It is connected with a dashed line to the last circle on the right hand side, the bottom circle, and then it is connected to the first circle on the second rectangle, and then it is also connected to the next circle using a dashed line. So you can see the path from this point, from the first rectangle to the second rectangle to the top rectangle, third rectangle, and then the fourth on the right hand side. And then you can see the physical copper connection set up when the call is made, and then when this call is connected, the entire circuit, the entire path has been established, and it has been found and it is vacant, then it can the destination phone can ring here. Okay, so this is how the circuit switching takes place in the telephone system. So what it is doing is, whenever you're dialing someone's number, it is basically finding the actual physical path from the source to the destination. And what do you mean by actual physical path? It is finding the actual in the switching offices, you have to just find out the path which is vacant. Now because now in this particular example, in this figure, you can see that there are only 3 connections from each exchange office, 3 incoming ports and 3 outgoing ports. So this is the very simplified version of the exchange offices, but you may have many more connections, input and output ports. So suppose there are maximum 50 input and 50 output ports in the local exchange. So at the most 50 phones from a local telephone exchange can be connected to the to any other telephone lines. So at the most 50 people in a particular area, particular village can be connected to other 50 people in any of the area in your country or maybe outside your country. So maximum 50 people can be connected. That is the limit. So but if but it's very rare that all the 50 people will be using the telephone system simultaneously at the same time. So we should have some maximum number, but in circuit switching, each one of them can be connected directly to any other telephone line, because there are 50 input ports and 50 output ports. So in the simplified version, we have just seen that there are 3 input ports and 3 output ports. Now, so in the early days, now we have seen the 3 incoming lines. So when a call passes through a switching office, a physical connection is conceptually that is established between the line on which the call came in and one of the output lines, as shown by the dotted lines. Now in the early telephone days, there was no automatic switching. So somebody has to be there in the telephone exchange, some telephone operator has to be there, and he used to use a Strowger gear. You can see here Strowger gear, and that was an equipment that was just a kind of jumper cable. He used to connect the 2 input and output ports. And like here you can see these 2 in the first rectangular box, the first 2 ports, the first on the topmost circle and the last on the right hand side, the last one in the second column circle, these are to connected using the jumper cable. So in earlier days, in the starting of the telephone system, there was some cable operator or the telephone operator who was sitting in the telephone exchange, and he used to make a connection between the 2 input and output ports. So that was done manually, but later on it was switching equipment was automatic switching equipment was designed, and it was installed in every telephone exchange, and it was done automatically. So this was circuit switching. So now this is this pic is only a simplified version, and because physical path जो आपका telephones के बीच में है पूरा का पूरा, it may contain the coaxial cables, it may contain the microwaves, it may contain the fiber links in between, and thousands of calls are multiplexed. So I have just told you an example, because this is 3x3 exchange we are just seeing, but it may happen that it could be, I gave you an example of 50 input port and 50 output ports, but in reality it may be thousands of calls at same time in a particular city or a particular town. So this is only a simplified version, and what we have shown through the rectangles and only the lines here, these lines are not the simple physical lines. These are not just coaxial cables or optical fibers. These can be satellite links. These can be the fiber optical links also. So any kind of transmission media you can use between the switching offices also, between these rectangles. So that is a part of the physical layer only, circuit switching. So another important property of circuit switching is it needs to set up an end-to-end path before any data can be sent. So as you know, before start speaking and before calling someone, we should have first a telephone connection between the sender and the receiver. So if we are calling someone, I cannot start speaking unless and until I am connected to that person. So that is the main property of a circuit switching. And as we discussed that whenever I am dialing someone's number, before it starts ringing on the other side, it will take at least 10 seconds. Okay, so why it is taking some seconds, 5 to 10 seconds, because, and it may take more time on a long distance or international call, because why it is taking so much of time? Because it during that 10 seconds of interval, the telephone system is searching for a path which is free. So you can see in figure 2.43 here that it is trying to find a path from the source to the destination. See, so this is a call request signal. So I'm dialing someone's number. In the first column you can see this is call request signal. So it is why there are some four or five parallel lines, because first parallel line is the sender, the second parallel line here, this is the distance between these two will be the distance between the two switching offices or two tall offices or end office, local loop. So I am sending from this point to the second parallel line. So it will take some time from one office to another office to connect and to find a path. Then there also it will take some time to find forward the particular signal, and the request of the circuit switching, this request call request signal will be sent to the other switching office. It will take some time. एक और आउटगोइंग लिंक में सर्च करेगा और दोबारा से फिर वहाँ से स्टोर एंड टाइम स्पेंट हंटिंग फॉर एन आउटगोइंग लिंक, फिर वहाँ पे जाके फिर वो एक और आउटगोइंग लिंक के लिए टाइम सर्च करेगा, एंड देन द थर्ड ग्रे horizontal slab will be there. So you can see the time is more in establishing and finding a actual physical path in the circuit. Then there will be some time taken by the destination to accept the call and send back the acknowledgement, which is the slant gray line. You can see here call accept signal here, and at this point of time, when this point comes, the actually when the bell has started ringing and its notification will be sent to your side. So this entire time will be taken to establish a connection circuit between the sender and the receiver. You can see this is the time, this time axis. So much of time will be taken in establishing and finding a actual physical path, and then the actual data can take place. So this is A to B path. These are four basically hops. So A is the sender, D is the receiver, but B and C are the switching hubs or switches, or the toll offices or the end offices, exchange offices. So A to B trunk, it will take the data will be sent, B to C and C to D. So there will be majorly the time taken here will be, the actual time taken here will be the time for establishing the actual physical path or the actual connection. So this is a circuit switching process. So now you can see the call request signal must propagate all the way to the destination and be acknowledged by the receiver. But what will happen, it will take so much of time. So in real life computer applications, suppose we have a point of sale credit verification. So you are verifying someone's credit card information and you want to sell some product. So for that, if you are setting with the receiver, or you are setting up a circuit switch network between, or a circuit switch call is there between the sender and the receiver, that is the person who is selling its product and the customer who is buying the product. And if you are trying to make a credit card verification, and then you are establishing a connection, it will take so much of time, long setup time will be there, but it will be undesirable, because the customer as well as the seller, they don't have so much of patience. So in that case, we can go for packet switching. Now, as a consequence of the reserved path between the calling parties, once the setup has been completed, the only delay for data is the propagation time for the signal, EM signal, about 5 milliseconds per 1000 kilometers. So also, as a consequence of the established path, there is no danger of congestion. That is, once the call has been put through, you never get busy signals. So of course, you might get one before the connection has been established due to lack of switching and trunk capacity. So it may happen that in this kind of switching technique, switching process, you may get busy signals before establishing the connection, before establishing the path between the sender and the receiver. But after you have established the path between the sender and the receiver, and the acknowledgement has been received by the receiver, sender, and the acknowledgement has been sent by the receiver, you will not get any congestion. So you can see in figure 2.43a, the time taken by the data to propagate from A to D will be the only time taken by the signal to propagate from A to B, B to C, C to D. So that there is no gap. You can see here in the picture down below that there is no gap. Can you see there? There is no gap between the data being sent, and it will only take the time for the data to propagate from one place to another or from source to destination. So there will be no setup time, there will be no congestion. Once the circuit has been established, there will be no congestion. This is the biggest advantage of circuit switching. But in contrast to circuit switching, we have nowadays we have packet switching, which is more desirable in context of the computer applications we are doing nowadays. So this is you can see here. So with this technology, packets are sent as soon as they are available. Now you can see here in this figure 2.43b. So now the actual time taken here will be only the propagation delay. So what you are doing is from point A to B, I am just sending the packets, packet 1, packet 2, packet 3, and they are being sent to the other part, B to C, packet 1, packet 2, packet 3, in that order only. Packet from point C to D, packet 1, packet 2, packet 3. So the only difference we have here is, suppose packet 1 was sent, you can see here packet 1 was sent, this is the queuing delay basically. So at each point, at each switching point, that is B and C here, you have a queuing delay. Instead of having a congestion in the during, or instead of having the time taken for establishing the circuit, as in circuit switching, we don't have any delay of establishing the circuit, but we have a queuing delay, because at every place, every switching point B and C, we may have a queuing delay. Some packets may be forwarded from other devices also. So this is in context of a single sender and receiver. So this pic is only for single sender and single receiver, but it may happen that at any switching point B and C, in between, in the intermediate switching points B and C, there may be some other people who are just dialing and who are just sending their data and the packets. So there may be thousands of packets being queued at the same point B and C, and the congestion will be there. So queuing delay will be there, and that because of that queuing delay, the packets as they are being transmitted, they may not be sent and forwarded to the other next hop. It may have some delay, because there are so many packets from the different senders and different to be sent to the different receivers, because you are doing multiplexing also. So now it is up to the routers to use store and forward transmission to send each packet on its way to the destination on its own. So now we are not bothered about establishing the circuit between the sender and the receiver, and we are not actually establishing the path between the sender and the receiver. What we are doing is we are just sending it to the next router, the next switch, and it is doing store and forward transmission. So it is storing, it is receiving it from, suppose B is receiving the packet which is being sent by A. So it is receiving the packet, storing it, and then forwarding it to the next hop, to C. C is receiving the sequence of packets, storing it and forwarding it as per its routing table. It is sending it to D. So it is doing store and forward transmission. Now this is unlike circuit switching, which is a result of connection setup, and it reserves a bandwidth all the way from the sender to the receiver. Now in this context, I would like to give you a real life analogy. Suppose you must have seen when some VIP or VVIP or some, suppose president or some chief minister or prime minister is going through some road and some path which you are traveling. Suppose you are going through some bus, or you are having your own car and you are going through the road, but some ways your traffic is being diverted, or your traffic is being stopped because someone else who is important, some VIP or some VVIP or some president or some chief minister is going through that path. You will have to face congestion, and you will have to face traffic also, because that traffic will be avoided, that will be stopped, and your cars will be stopped on one side of the red light, and then or you may have to just wait for that traffic to go, and then you will be then again allowed to go forward. So that is because that path is not dedicated. But from the perspective of the prime minister or that VIP person, or from the perspective of chief minister, that whole path has been dedicated to the chief minister and there is no congestion. So for those types of priority based and high security, high authentic, reliable communication, you should have a switching path. So suppose like on 15th August and 26th January, on any other special days when your ministers, your chief ministers and prime ministers and presidents are going through a particular path, all the defense forces, they just ensure that a particular dedicated path from their source to destination where they want to go, suppose from their home, maybe Raj Bhavan to the Rajghat, or somewhere the public place, or maybe to the Lal Killa if they wish to travel, they just establish the path and they don't allow anyone. For that time duration when that function is going on and when the prime minister is going to travel from that place, they don't allow anyone else to go from that place. So that path, entire circuit, that entire path is dedicated to only the person who will be traveling, the VIP person that will be traveling through that path. That is circuit switching. So for the entire duration, no one is traveling and no one is using that road. Still, what's happening? We have dedicated that part, so that bandwidth is wasted for that duration. So in normally if you don't have those kinds of things, we don't use circuit switching on the roads. So ऐसा नहीं है कि अगर आप कोई नॉर्मल पर्सन है तो हर एक के लिए अपनी अपनी रोड होगी, किसी को सबको डेडिकेटेड पाथ मिल गया, आपको अगर ऑफिस जाना है तो आपको सिर्फ एक डेडिकेटेड रोड मिल गई और वहीं से आप ऑफिस जाओगे, ऐसा नहीं है. So each of you will be sharing all the roads. So कनेक्शन सेटअप क्या करता है, बैंडविड्थ रिजर्व कर देता है फ्रॉम सेंडर टू रिसीवर, एंड डेटा ऑन द सर्किट फॉलोज दिस पाथ. और पूरा का पूरा जो डेटा है, पूरा का पूरा जो आपका सेट ऑफ व्हीकल्स हैं जो कि VIP पर्सन के साथ हैं, दे विल फॉलो द सेम पाथ. सो अदर प्रॉपर्टीज आर the data follow the same path, means it cannot arrive out of order. अब जो आपका जो पूरा VIP का पूरा जो वो पूरा ग्रुप है, VIP जो केडर के जो ग्रुप के लीडर्स हैं, जो भी है पूरा जा रहा है, आपका पूरा सेट ऑफ व्हीकल्स जा रहे हैं, दे विल ऑल फॉलो द सेम ऑर्डर. दे कैन नॉट अराइव आउट ऑफ ऑर्डर. अगर पहले आपको 10 गाड़ियाँ भेजनी है सिक्योरिटी पर्पज से, उसके बाद कुछ आपको और व्हीकल्स भेजने हैं, फिर उसके बाद प्राइम मिनिस्टर की गाड़ी आएगी, उसके पीछे भी फिर 10 व्हीकल्स आने हैं. सो ऑल दे विल फॉलो द सेम ऑर्डर, एंड जिस ऑर्डर में वो सेंड हुए हैं उसी ऑर्डर में वो जाएंगे. जैसे कि टेलीफोन सिस्टम में, एक बार मैंने टेलीफोन सिस्टम में अगर मैं अपना डेटा वॉइस भेजना शुरू कर दूँ, मैं जिससे बोल रही हूँ, जिस ऑर्डर में मैं अपना डेटा सेंड कर रही हूँ, वॉइस जिस ऑर्डर में मेरा वॉइस पैकेट्स आ रहे हैं, उसी ऑर्डर में आपको मिलेंगे. ऐसा नहीं है कि मैंने एक सेंटेंस 2 मिनट पहले बोला था और वो सेंटेंस आपको 2 मिनट बाद मिल रहा है. दिस इज नोन एज connection oriented service. So the packets are sequenced, they are in order, and they will follow the same path and they will not arrive out of order. This is the main advantage of circuit switching. Now with packet switching, there is no fixed path, and so different packets can follow different paths depending on network conditions at the time they are sent, and they may arrive out of order. So suppose when you are driving and you are suppose 2 people started from the same place and they are following different paths. Some people, they know the shortcuts, they know how to travel through Delhi roads, and they may follow shortcut paths and they may arrive early as compared to you, and you are following the straight path and you may arrive out of order. So the people who started later, they may arrive early, but you started earlier, you may arrive late. That is out of order. Then packet switching networks, they have upper limit on the size of packets also, because ऐसा नहीं है कि आपको कोई भी पैकेट भेजना है तो अगर आपको अभी रोड खाली मिला, पूरी बैंडविड्थ खाली मिली है तो आप बहुत सारा डेटा भेज दो, ऐसा नहीं है. You have the limit on the packets to be forwarded. This ensures that no user can monopolize any transmission line for very long. ऐसा नहीं है कि आपने अपने ही 10 ट्रक भेज दिया. आपको अगर आप यू आर अ बिजनेसमैन एंड इफ यू वांट टू यूज द रोड, यू आर सेंडिंग योर ट्रक्स ओनली फॉर द होल डे. नो, you can send only a limited data and others are also occupying the same bandwidth and they are using the same link. Now packet switch networks, they can also handle the interactive traffic, because they are allowing the packets from every user, not the dedicated users. So they are allowing every user to send the packets, but it also introduces delays since the first packet of a long message can be forwarded before the second one has fully arrived. अब ऐसा नहीं है कि आपका जो है अब नेटवर्क लेयर से डेटा आपका आ रहा है और आप उसको डेटा लिंक लेयर पे भेज रहे हो, तो आपका सपोज बड़ा पैकेट है और जो कि 10 फ्रेगमेंट्स में 10 आपने पैकेट्स में सब पैकेट्स में डिवाइड कर दिया, तो पहला आपने फॉरवर्ड किया तब तक सेकंड जो है वो भी अराइव हो गया, तो आपका जो है इट मे कॉज सम डिले, क्योंकि अभी सेकंड पैकेट आया ही नहीं है, सब पैकेट आपने पहला फॉरवर्ड कर दिया है, तो इट हैज़ टू वेट. बट स्टोर एंड फॉरवर्ड डिले ऑफ एक्यूमुलेटिंग अ पैकेट इन द राउटर्स मेमोरी बिफोर इट इज सेंड टू द नेक्स्ट राउटर एक्सीड्स दैट ऑफ सर्किट स्विचिंग. आपका कभी कभी जो है ये डिले जो विद द सर्किट स्विचिंग पैकेट स्विचिंग है, इट मे एक्सीड द टाइम. ओके, विद सर्किट स्विचिंग द बिट्स जस्ट फ्लो थ्रू द वायर कंटिन्यूसली. तो आपका कई बार हो सकता है कि पैकेट जो है फॉरवर्ड होके आ रहा है और वो आउट ऑफ ऑर्डर आया है, तो आपके नेटवर्क लेयर को उसको ट्रांसफर करने में टाइम लगेगा. सो इट हैज़ टू वेट फॉर ऑल द सब पैकेट्स टू अराइव एट द डेटा रिसीवर्स डेटा लिंक लेयर सो दैट इट कैन क्लब ऑल ऑफ देम इन ऑर्डर एंड इट कैन सेंड इट टू द नेटवर्क लेयर. सो दिस इज द sometimes this is the disadvantage of packet switching, but with circuit switching the bits they were flowing in the same continuous manner as they are arriving from the other side. So that is the advantage of circuit switching. Now they both differ, packet switching and circuit switching, they both differ in various ways. Now like in I told you that in packet switching there are some queuing delays because there is no reserved bandwidth. So packet switching packets may have to wait to be forwarded, and it may have to face a congestion also because so many people the users are sending and forwarding through the same switches. So they may have packets from various different sources to be sent to the different destinations, therefore you have queuing delays. But in packet switching there is no danger of getting a busy signal and being unable to use the network. ऐसा नहीं है कि आपको अभी आपने ट्राई किया और आपका भी नेटवर्क बिजी है तो आप उसको कॉल ही नहीं कर पा रहे पर्सन को. What you have done is as soon as सब पैकेट हैज़ अराइव यू हैव स्टार्टेड सेंडिंग इट एंड स्टोर एंड फॉरवर्ड टेक्निक के थ्रू आपने उसको पैकेट्स को स्विच करना शुरू कर दिया, सेंड करना शुरू कर दिया. आपको उसका वेट नहीं करना पड़ा कि आपने अभी लाइन को डायल किया, सर्किट स्विच एस्टैब्लिश करने की कोशिश की, और अगर सपोज देयर आर थाउजेंड्स ऑफ यूजर्स हु आर ऑक्यूपाइंग द सेम बैंडविड्थ यूजिंग सर्किट स्विचिंग, तो आप जो 1001th यूजर है वो बिल्कुल भेज ही नहीं पा रहा. सपोज 1000 लोग हैं, ठीक है, और 1000 लोग जो है सारे के सारे सब्सक्राइबर्स हैं, जो यूज़र्स हैं वो सारे के सारे घंटे भर तक अपना फ़ोन कॉल पे लगे हुए हैं यूजिंग सर्किट स्विचिंग. व्हाट्स हैपनिंग, जो 1001 वाला यूज़र है वो बेचारा वो यूज़ ही नहीं कर पा रहा ड्यू टू द लाइन बिजी. बट इन पैकेट स्विचिंग अगर आप करते हो तो सबके ही पैकेट्स चाहे 1001 वाला भी जो यूज़र है वो भी अपना पैकेट भेज पा रहा है. बस हाँ थोड़ा सा कंजेशन है, बट ही विल बी एबल टू कम्युनिकेट इट्स पैकेट थ्रू द पैकेट स्विचिंग टेक्निक and the line will not be busy for too long. That is the advantage of packet switching. Now if a circuit has been reserved for a particular user and there is no traffic, its bandwidth is wasted. And suppose मैंने एक नॉर्मली अगर मैं मोबाइल से कॉल नहीं कर रही हूँ, आजकल की पैकेट स्विचिंग टेक्नोलॉजी नहीं यूज़ कर रही हूँ, एंड थिंक ऑफ द ओल्डर ट्रेडिशनल टेलीफोन सिस्टम्स, अगर मैंने फ़ोन कॉल कर दिया और मैंने कहा कि वेट करो 2 मिनट मैं अभी आई, ठीक है, तो क्या होगा कि मैंने जो सर्किट एस्टेब्लिश किया है मैं टेलीफोन को छोड़ के हैंग करके और मैं चली गई हूँ, एंड द होल पाथ द होल सर्किट जो क्योंकि आपने फिजिकल पाथ एस्टेब्लिश किया था सोर्स से डेस्टिनेशन तक, वो सारा का सारा अभी तक मैं होल्ड करके भूल गई हूँ फ़ोन को, और मैं 5 मिनट सब्जी बनाने चली गई हूँ या चाय बनाने चली गई हूँ, और 5 मिनट के बाद आके दोबारा से मैंने फ़ोन को पिकअप किया और दोबारा से मैंने बात करनी शुरू कर दी. दैट्स नॉट द वे, बिकॉज उसमें क्या हो रहा है, बैंडविड्थ वेस्ट हो रही है. फॉर दैट 5 minutes of duration when I am not doing anything and I am not sending any data on the telephone line, the bandwidth is wasted and no other user can connect to the telephone network. That is the disadvantage of circuit switching. Then packet switching does not waste bandwidth and thus is more efficient from a system's perspective. So understanding this trade-off is basically you can find the difference between the circuit switching and packet switching, that there is a trade-off, that either you can wait for the network to be free and you can establish a full-fledged connection from the source to destination, that is circuit switching, or you are wasting the bandwidth also, but you don't want to waste the bandwidth, you want to utilize it efficiently and you want to accommodate more number of users in the packet switching, but with some queuing delays. So that is up to you which kind of communication network you want to design. Then one is guaranteed service and wasting resources, that is circuit switching, versus not guaranteeing any service but not wasting the resources also, that is packet switching. Now packet switching is more fault tolerant than circuit switching. In fact, that's why we have invented packet switching. If a switch goes down, all of the circuits using it are terminated and no more traffic can be sent on any of them. Now think of the telephone exchange. कभी कभी क्या होता था पुराने टेलीफोन लाइंस में, लैंडलाइंस में, कि आपका अगर टेलीफोन एक्सचेंज में कुछ प्रॉब्लम आ गई, आपका स्विच खराब हो गया, तो सर्किट स्विचिंग के केस में क्या होगा, जितने भी सब्सक्राइबर्स उससे कनेक्टेड थे, एंड लूप से कनेक्टेड थे, जितने भी सपोज लोकल सब्सक्राइबर्स कनेक्टेड थे, सारे के सारे डाउन, क्योंकि एक्सचेंज में कुछ प्रॉब्लम है तो दे कैन नॉट कनेक्ट टू द आउटसाइड वर्ल्ड. तो वो स्विच डाउन होने से सारे के सारे जो उसके लोकल सब्सक्राइबर्स है सबके सब टेलीफोन नहीं कर पाते थे, तो क्योंकि आपका टेलीफोन एक्सचेंज में कुछ प्रॉब्लम, लोकल टेलीफोन एक्सचेंज में प्रॉब्लम थी. बट विद पैकेट स्विचिंग आपका अगर स्विच खराब है कोई बात नहीं, आपको सर्किट एस्टेब्लिश नहीं करना है, कोई और स्विच अगर ठीक है तो उस स्विच से आपके कनेक्ट करके पैकेट्स को रिसीव कर सकते हो आप और उनको सेंड कर सकते हो. तो आज इस कॉन्टेक्स्ट में आपका पैकेट स्विचिंग इज मच बेटर. Now the final difference between circuit and packet switching is the charging algorithm. अब charging algorithm means कि आप चार्जिंग कैसे करोगे, कैरियर जिसके थ्रू आप सिग्नल्स भेज रहे हो, EM वेव्स को भेज रहे हो, जो डेटा को भेज रहे हो, वो उसको चार्ज कैसे करोगे, कैरियर को, मतलब जो आपका EM वेव्स को कैरी कर रहा है. ठीक है, दैट मीन्स अगर आप लैंडलाइन की बात करो, आजकल लैंडलाइंस क्यों नहीं ज़्यादा लोग यूज़ करते हैं, कि बिकॉज इट बिकम्स वेरी एक्सपेंसिव, क्योंकि वहाँ पर आप डेडिकेटेड एक सर्किटरी आप इमेजिन कर रहे हो या उसके लिए डिमांड कर रहे हो कि डेडिकेटेड आपका सर्किट होना चाहिए फ्रॉम सोर्स टू डेस्टिनेशन. तो वहाँ पर यू आर द टेलीफोन कंपनीज एंड ISPs, दे आर बाउंड टू हैव अ डेडिकेटेड कनेक्शन फॉर ऑल ऑफ यू or for all the subscribers, so it will be charging more. So and that was based on the distance and the time. You अगर आपको याद हो तो पहले जो पुराने सिस्टम्स होते, टेलीफोन सिस्टम्स होते थे, उनमें जो बिल आता था वो कैसा था, लोकल कॉल, STD कॉल एंड ISD कॉल, और कितने टाइम के लिए आपने कॉल किया है उस पर बेस्ड होता था आपका बिल. तो अगर ज़्यादा लंबी कॉल्स होती तो आपका बिल ज़्यादा आता था टेलीफोन सिस्टम का, टेलीफोन लाइन का, और अदरवाइज़ अगर आपका छोटी छोटी कॉल्स की, आपने लोकल कॉल्स की, तो आपका टेलीफोन का बिल कम आएगा. सो चार्जिंग वॉज बेस्ड ऑन द metrics of distance and time. But for mobile phones nowadays distance usually does not play a role, क्योंकि आप चाहे चेन्नई में बैठे हो, चाहे आप कलकत्ता में बैठे हो, आपने अगर मोबाइल टू मोबाइल कॉल किया है और सेम ISP वाले से किया है, सेम सर्विस प्रोवाइडर से किया है, सपोज एयरटेल टू एयरटेल या वोडा टू वोडा या जियो टू जियो, तो आपकी कॉल्स will have the same rate. It doesn't matter if you are sitting at Visakhapatnam or you're sitting in Jammu and Kashmir, wherever you are sitting, the phone calls will have the same charges. So it does not play a role except for international calls. अगर आप ISD करते हो तब उसमें आपको फ़ोन कॉल्स ज़्यादा महंगे पड़ते हैं, and the time plays only a small role, क्योंकि आपका ज़्यादातर आप कॉलिंग प्लान के साथ मोबाइल सिस्टम्स में चलते हो. तो these are all mobile phones are based on the concept of packet switching. So and with packet switching, connect time is not an issue. कितने टाइम के लिए भी आप बात करो, it doesn't matter, but it does matter that the volume of the traffic इज लार्ज और स्मॉल. सो आप कितना डेटा अपलोड कर रहे हो, कितना डाउनलोड कर रहे हो. अगर आप फ़ोन कॉल करते भी रहते हो, इंटरनेट कॉल करते हो, सपोज जैसे गूगल मीट करते हो या व्हाट्सएप कॉल करते हो, तो आप जब इंटरनेट कॉल कर रहे हो, इट डजेंट मैटर कि आप 1 घंटा बात करो कि 2 घंटे बात करो कि 4 घंटे बात करो. इट डजेंट मैटर, बिकॉज वहाँ पर आपका टाइम बहुत कम मैटर करता है. वहाँ पर मैटर करता है कि आप कितना फाइल अपलोड कर रहे हो. जैसे अगर आपका 1 GB का डेटा है या 2 GB का डेटा पर डे आपको मिल रहा है किसी प्लान में, मोबाइल फ़ोन में, तो आपका क्या हो रहा है कि आप 2 घंटे भी बात करो, दिन में 10 घंटे भी बात कर ली किसी से, तब भी आपका डेटा खत्म नहीं होगा, क्योंकि कॉल में आपका डेटा ज़्यादा नहीं जा रहा है, टाइम में वो नहीं जा रहा है. लेकिन आप जो डेटा, क्योंकि इसमें सिर्फ आपका वॉइस डेटा जा रहा है, लेकिन अगर आप कोई फाइल शेयर कर रहे हो या फाइल को डाउनलोड कर रहे हो या अपलोड कर रहे हो, उसमें डेटा ज़्यादा यूज़ होता है. तो अगर आप यूट्यूब वीडियोज़ देखते हो या इंस्टाग्राम पे सिंपल टेक्स्ट मैसेजेस करते हो, डजेंट मैटर. व्हाट्सएप पे टेक्स्ट मैसेजेस करते हो, तब भी आपका 1.5 और 2 GB डेटा ज़्यादा मैटर नहीं करता. लेकिन अगर आप उससे बात कर रहे हो, क्या बोलते हैं, अगर आप सिंपल कॉलिंग कर रहे हो, ठीक है, तो उस केस में आपका कुछ अपलोड कर रहे हो, डाउनलोड कर रहे हो, या कोई वीडियोस देख रहे हो, वीडियोस को सेंड कर रहे हो, अपलोड कर रहे हो या डाउनलोड कर रहे हो, किसी फ्रेंड ने भेजा है, या फोटोज़ को सेंड कर रहे हो, तब आपका डेटा ज़्यादा यूज़ होगा. ठीक है. सो दैट इज़ फॉर पैकेट स्विचिंग. So now we can see the difference between the two circuit switching and packet switching. The call setup time, call setup is required for circuit switch network, but for packet switch there is no call setup required. Dedicated physical path, yes, there is a exact dedicated physical path, but for packet switch there is no physical path. Now I would like to mention here, dedicated physical path means it may be some if it is through the wired medium, coaxial cable, twisted pair or optical fiber, you will have a dedicated wire medium. Okay, and the dedicated wire will be installed from your home to the local telephone exchange or the local ISP. But it is not always the wired medium. It may be the microwave, it may be the radio frequency range, it may be any other medium. So if it is a wireless medium, then in wireless medium it is dedicated physical path is the actual frequency domain which has been allotted to you. So suppose अब मैं आपसे बात कर रही हूँ या मैं आपको फ़ोन कॉल कर रही हूँ, तो मुझे एक फ्रीक्वेंसी, पूरे फ्रीक्वेंसी डोमेन में से एक पर्टिकुलर 300 kHz तक की फ्रीक्वेंसी, बिकॉज वाई 300 kHz frequency, because I am talking, I am sending a voice signal, so I will be allotted a frequency domain dedicatedly if I am using the circuit switching technique. Okay, so that is the actual physical dedicated physical path. जब तक मैं फ़ोन कॉल कर रही हूँ, पहले भी जब ट्रेडिशनल फ़ोन कॉल्स होते थे, STD और ISD होते थे, तब भी आपका जो माइक्रोवेव या इसमें EM स्पेक्ट्रम में जब हम वायरलेस मीडियम यूज़ करते थे, सैटेलाइट मीडियम, उसमें भी एक पर्टिकुलर फ्रीक्वेंसी डोमेन हमें अलॉटेड होता था. तो जब तक कि I was on call using the telephone and circuit switch technique, तब तक वो फ्रीक्वेंसी जो है एक ही पर्सन को अलॉटेड रहती थी. बाद में व्हेन आई गॉट डिस्कनेक्टेड, तो वो एक्चुअल डेडिकेटेड फिजिकल पाथ, दैट इज दैट फ्रीक्वेंसी वाज डीएलोकेटेड एंड एलोकेटेड अगेन टू सम other subscriber which used to which wants to have a STD call or ISD call. तो ये dedicated physical path का मतलब ये नहीं कि आपको हमेशा एक वायर बिछानी है बीच में. It can be a wire or it can be a wireless medium. Then next is each packet follows the same route. सर्किट स्विच में हर एक जितने भी पैकेट्स हैं, दे आर जस्ट फॉर्मिंग अ पाइप लाइक स्ट्रक्चर, और आपका सोर्स से जिस ऑर्डर में आए थे पैकेट्स, उसी ऑर्डर में रिसीवर को डिलीवर हो जाएंगे. बट फॉर पैकेट स्विच दैट्स नॉट द केस. देन पैकेट्स अराइव इन ऑर्डर, yes, in circuit switching, but in packet switching, no, they may arrive out of order, they may follow different path, so they may arrive out of order. So is a switch crash fatal? Yes, in circuit switching it is fatal, but in packet switching it is not fatal. Bandwidth is available and fixed to all, the sender and the receiver for the entire duration of time in circuit switching, but not it is dynamic. Bandwidth is dynamic in case of packet switching. Now why dynamic? Because अभी अगर मैं सपोज सर्किट स्विचिंग कर रही हूँ, तो मेरे को पूरी की पूरी फ्रीक्वेंसी रेंज उसमें अलॉटेड होगी. लेकिन इन केस ऑफ पैकेट स्विचिंग मेरे पास डायनामिक बैंडविड्थ है कि कभी कभी मेरा जो है डेटा स्लो भी हो सकता है, कभी कभी मेरा डेटा फास्ट भी सेंड हो सकता है. सो इट विल टेक टाइम एंड इट इज़ डायनामिक बेस्ड ऑन द नंबर ऑफ यूजर्स हु आर यूजिंग द पैकेट स्विचिंग नेटवर्क. नाउ टाइम ऑफ पॉसिबल कंजेशन. कंजेशन जो टाइम है वो सिर्फ सेटअप के टाइम पे होगा अगर मैं सर्किट स्विचिंग यूज कर रही हूँ, बट अगर मैं पैकेट स्विचिंग यूज कर रही हूँ तो ऑन एवरी पैकेट देयर विल बी सम पॉसिबल कंजेशन बिकॉज it may have to face a queuing delay in case of packet switching. And is there any potential waste of bandwidth? Yes, in circuit switching we can waste the bandwidth if we are not utilizing for the whole duration and if we are not using the entire capacity of the spectrum. In packet switching there will be no wastage of bandwidth. If there are more number of users to use that packet switching network, they may be accommodated based on the they may be accommodated, but with maybe with the some queuing delay or congestion delay. Store and forward transmission technique is not used in circuit switching, but it is used by packet switching networks. And charging is based on the per minute in circuit switching, but per packet charging is done in packet switch networks. So these are the differences and the comparisons between circuit switching and packet switch networks. Okay, so this, I think here we can stop now for this. That's all for switching. Okay, so let me move to another small topic, that is point-to-point protocol. Are you all there?
Yes, ma'am.
Any doubts in circuit switching and packet switching?
No, ma'am.
No doubts, all clear? Or overhead transmission is going on?
No, ma'am.
Do you understand OHT?
Yes, ma'am.
Yeah, that is the term used for communication, networking and communication. So that is a very popular term, that is OHT, is overhead transmission. So sometimes you may not understand what I am teaching. So then it will go above your head, over your head. Okay, so that is the transmission going above your head. Anyways,
You understand its meaning.
what?
Yes, ma'am, we understand its meaning. Overhead transmission.
Okay, fine. So, so it is in-head transmission,
Yes, ma'am.
IHT, okay? Fine. So, start with the remaining topics we left in the last class, that is point-to-point protocol. So, next is point-to-point protocol, which because we are starting with the data link layer now. So data link layer, because now we have finished everything in physical layer, so we are moving towards data link layer. And in the last class also, I think we discussed stop and wait protocol with acknowledgement and without acknowledgement, and with sequence numbers and without sequence numbers. So in continuation to that, I'll be discussing in short point-to-point protocol. What do you mean by point-to-point protocol? Because in basically till data link layer, we assume that we are not doing any routing. We are just forwarding the packets which are coming from one end of the link to the other end of the link. So that is point to point. So there is some link. It may be the wired link or it may be the wireless link between the sender and the receiver. So from one end of the point link to the another end. So that is point to point. So therefore we have PPP protocol or point to point protocol in data link layer. And what are the services provided by the point to point protocol? We say that it defines a frame format to be exchanged between the devices, because as we all know that data link layer is between the network layer and the physical layer. Fine. So network layer is sending some packets from above, because it is receiving from the application layer some data or message from the application layer, then the transport layer, then network layer. So network layer will have some message in the form of a packet. Then data link layer will receive it and then it will send it to the physical layer. But physical layer and actual physical transmission media is only interpreting the bits. It can only understand the. So this PPP protocol basically in the data link layer is responsible making frames, and it defines a frame format which should be exchanged between the devices connected through that direct link in the data link layer. So it also describes how two devices can negotiate the establishment of the link and exchange of data. So PPP is designed to accept from several network layers, not only IP. What I mean, because we have assumed that the network layer is basically, because we are discussing primarily TCP/IP model, so we assume that network layer is running IP protocol at network layer, but it may happen that some other network layer protocol will be used at the network layer. So the data link layer protocol should be able to understand any format of the protocol which is being used at the network layer. So कोई भी पैकेट फॉर्मेट हो सकता है, कोई भी प्रोटोकॉल यूज हो सकता है नेटवर्क लेयर पे, और डेटा लिंक लेयर पर जब हम वापस आएंगे तो वहाँ पर डेटा लिंक लेयर प्रोटोकॉल शुड बी एबल टू अंडरस्टैंड एनी फॉर्मेट coming from the network layer. So this is the basic design of the protocol, PPP protocol. So it can take any type of format from the network layer. Then authentication is also provided in the protocol, but it is optional. Authentication means whether it is getting the data frame from the authentic connection, authentic link or authentic source. Then the new version of point-to-point protocol is also called multi-link PPP, which says it can have connections from multiple links on the same line. And one more feature of PPP is that it provides network address configuration. What do you mean by network address configuration? Suppose I just want to connect through this point-to-point protocol. So if I am not connecting always to the network, whenever I am connecting to the network, I should have some IP. So I should be given some temporary IP address, so network address or IP address. So the dynamic IP configuration or allotment should also be provided by the PPP. So it is the interesting feature done by PPP nowadays. So there are some services which are not provided by the PPP. PPP does not provide flow control. What do you mean by flow control? Now suppose I am sending the data, I am delivering the lecture continuously, and you are not getting anything in your head. So it is going OHT, not IHT. Fine. So because I am sending too much of data in a shorter span, 1 hour class. So that is flow control. So PPP does not do flow control. Sender can send several frames one after another with no concern about overwhelming the receiver. So PPP, but we discussed flow control and error control in the last class. Error control means whatever the data is being sent by the sender, that is properly received by the receiver data link layer or receiver side of the data link layer. So PPP क्या करता है? Flow control तो नहीं करता है, but it does a little bit of or simplistic error control in the form of CRC. So when it is doing framing, it appends the CRC field with the frame to detect all the errors which are there in the frame. So if the frame is corrupted, it is silently discarded. So it does not do anything to repair the frame, but it silently discards. If the CRC is not correct, it will discard the frame, and sequence numbering may cause a packet to be received out of order. So there is lack of error control and sequence numbering also. तो ऐसा भी हो सकता है कि आपका because there is no sequence numbering, so packets may arrive out of order, and there is lack of flow control also. So the packet may be silently discarded, just checking if the CRC is not correct. And it does not provide a addressing mechanism also to handle frames in a multi-point configuration, as we discussed above. So then we have the concept of framing. So in short, we'll discuss framing in this chapter. The framing will be discussed at full length in from next book, the next class tomorrow. So PPP uses a character-oriented, byte-oriented framing, and you can see here, this is the frame 11.20 figure, and it shows the PPP frame. Now you can see this is one frame, and frame has two flags. You can see at both ends, left and the right end, 1 byte sequence of bits, that is flag. So आपका जो frame start होगा, how will the data link layer at the, so it will have flags at the starting of the frame and the ending of the frame, and the flag bit pattern, PPP frame starts and ends with a 1 byte of flag with the bit pattern of 0, 6 ones and zeros. Then addresses, the address field is in this protocol is a constant value and it is set to all ones, that is the broadcast address. Then we have the control field is set to the constant value of 6 zeros and double ones, which are unnumbered frames, because we are not doing sequencing. Sequence numbering is not being done, and it does not provide any flow control and only error control. So that is just wait. Then we have the protocol field. Protocol is 1 to 2 bytes depending on what has been agreed upon by both the parties, sender and the receiver side. So this can be 1 byte long, it can be 2 byte long. एंड देन द पेलोड फील्ड कि आपका नेटवर्क लेयर से वो पेलोड फील्ड कितना पैकेट्स का साइज होगा, कितना पैकेट्स फील्ड वो एक्सेप्ट करेगा. सो नॉर्मली फॉर ईथरनेट एंड इंटरनेट लैंस वी हैव 1500 बाइट्स, मैक्सिमम 1500 बाइट्स of data length which can be carried in one frame. And then FCS is frames check sequence, which is basically the CRC check. हम जो यहाँ पे CRC कोड डालेंगे for checking the frame sequence, case frame is in order or not. So that could be 2 bytes or 4 bytes depending on the standard of CRC we are using. And the last one is byte stuffing. So अब मैंने बोला कि मैंने ये बिट्स भेजे हैं डेटा लिंक क्लियर में. अगर मैं ये बिट्स भेजती हूँ फ्रेम में, फ्लैग यहाँ से फ्लैग से मेरा स्टार्ट होता है लेफ्ट हैंड साइड से, और राइट हैंड साइड के फ्लैग में मेरा एंड हो जाता है एक फ्रेम. तो अगर ये वाला जो बाइट है ये मेरी जो डेटा सीक्वेंस में पेलोड फील्ड में अगर आ जाता है यहाँ पर, तो मैं क्या करूँगी. तो उसमें आप क्या करते हो, एक एस्केप कैरेक्टर लगा देते हो. यू नो एस्केप कैरेक्टर्स इन C++, एस्केप सीक्वेंसेस, यू नो anyone? Escape sequences, have you done in C++?
Yes, ma'am.
Yes, ma'am.
What are escape sequences? What are escape sequences? Can you give me an example of escape sequence? Yes, Muskan, can you give me an example of escape sequence?
I'm like a backslash and then backslash T, some like.
Yeah, so all these are basically escape sequences. तो अगर आपका जो है नॉर्मल अगर डेटा में अगर आपको टैब डालना है तो आप /T यूज़ करते हो, ठीक है. या आपको अगर स्पेशल कैरेक्टर्स डालने हैं तो आप एस्केप सीक्वेंसेस यूज़ करते हो. सिमिलरली अगर आपका बाइट स्टफिंग का मतलब है कि अगर आपका जो फ्लैग सीक्वेंस है, फ्लैग सीक्वेंस हमारा क्या है 0, 6, 1 एंड 0s. तो अगर आपका ये वाला बाइट अपीयर हो जाता है डेटा में तो आप एक एस्केप कैरेक्टर लगा देते हो. और एस्केप बाइट का जो वो पैटर्न है वो क्या है, एस्केप बाइट इज 0, 5 1s, 0 and 1. So this byte will be inserted and then that byte will not be treated as flag pattern. So वो flag की तरह यूज नहीं होगा. This will be treated as normal data. So this is escape byte. Similarly अगर ये escape byte दोबारा से आ जाता है तो इसके लिए एक और escape byte यूज करेंगे. This is not known as byte stuffing. Then we have transition phases. I'll just rush through this because we'll discuss it in the next chapter in detail. So you can see when the data link clear, both the sides are not connected and there is no data transfer. Both the machines are in dead state. Then when the carrier is detected and some data bits and frames are being transmitted from one side, then the connection will be established, and there may be some authentication required because there may be some new user or new source connected to the link. Then you can do authentication, and if the authentication is successful, you can go to the network layer and send the data to the network layer. Then network layer configuration will be done and the data transfer will start. It will be in the open state. From the open state, when you are done and you will send the last data end of file, then it will be done and you can terminate the connection and the carrier will be dropped and you will go back to the dead state. So this is basically the transition phase. This is a finite state machine which is depicting the various phases of transition of a data link clear device, the sender and the receiver devices. So we'll discuss framing in detail in the next chapter, that is the third chapter from Tenenbaum, the second book. Okay, so let me finish here for today. So be ready for that means. Akriti,
Ma'am, she is present.
Ahana,
Present, ma'am.
Aishwarya,
Ma'am.
Anam,
Present, ma'am.
Ananya,
Present, ma'am.
Anjali,
Present, ma'am.
Anjali Pawar,
Present, ma'am.
Akriti, sorry, Anshika, Anshika, Asmi, Astha Singh,
Present,
Asmi
ma'am.
Dhyani is present.
Ayushi, Ayushi is absent. Bani Singh,
Ma'am, she is present.
Bhavna,
Present, ma'am.
Bhavna Chaturvedi, Diksha, Divyanshi, Harmeet,
Present, ma'am.
Himani,
Present, ma'am.
Janvi,